Section 7.3, the central limit theorem for sample proportions. Okay, the central limit theorem you will see referred to as the CLT for short says, if you take a random sample of a population, and if the sample size is large and the population size is much larger than the sample size, then the sampling distribution of p hat is approximately normal with mean p and standard deviation equal to the standard error. Okay, so that's the description in words. In symbols, what this is saying here is if we meet these certain conditions, then the sampling distribution will be approximately normal with mean p and standard deviation equal to the standard error formula that we learned in section 7.2. Now, this central limit theorem is a huge driving theorem in statistics, and it's one that we will call upon and check the conditions for and use for the rest of this semester. So this one's a really big, important one. So let's look a little closer at the conditions and how we're going to check them. The first one is that random and independent idea that your sample must be collected randomly. That's honestly what we're usually looking for. We're usually looking for that word random or randomly in the wording of the question. Now, if you're just looking at the data, you may not be able to see this. If it's just raw data, numbers in a spreadsheet, you may not know how it was collected. So you need to either have the researchers say so that it was randomly collected, or you as the researcher would have to make sure that it was. Every once in a while, you might have to just assume this one in order to continue, but most of the time, we're going to be just looking for that keyword. As long as that's present, we can check that one off our list. The second condition here is that we need a large sample. So it says the sample size in has to be large enough that you expect at least 10 successes and at least 10 failures. So you have to have a big enough sample that you expect kind of 10 of each way. Mathematically, what we're checking is that NP is greater than or equal to 10, and that N1 minus P is greater than or equal to 10. Okay, so here's our example for that. It says if you take a sample of 100 people, was 100 people enough? That's what's left to be determined here. If we sample 100 people and we're estimating the proportion of females in the entire world, the sample came back with 49% females. Okay, so we want to check, was the sample big enough that we got 10 successes and 10 failures for the female question here? Okay, well, N was my sample size, and P is this percent. So is that greater than or equal to 10? Sure, it's 49. And then failure would be the other way around. Failure in this case just meaning not what we were looking for. So we were looking for females, so the other 51%, or the 1 minus this, or I'll write it that way, the 1 minus 0.49, is that bigger than 10? Well, that's 100 times 0.51, which is 51. So yes, both of those check out. And then the last check we have to do is, was the population itself big enough? If the sample's collected without replacement, then the population must be at least 10 times bigger than the sample size. So this is going to look like a check that we did last section in section 7.2. So it says if N is the number of people in the whole population and little n is the sample, we have to check that that whole population is bigger than 10 times the sample. Okay, so let's see. The whole population here, well, the whole population here is the world. So is the world population greater than or equal to 10 times the sample size? Are there more than 1,000 people in the world? Yes.